Alright, you should be watching the life cycle of a star video at this point, and have your foldable out so that you can complete the tabs. I'll direct you on what tab you should be on as we go through this video. Your title page should be Beyond Earth. The first tab is Solar System. A star or a group of planets that revolve around the sun. A star or a group of planets that revolve around the star is what we define a solar system as. Our solar system, it revolves around the sun, which is our star. It has 9 planets and thousands of asteroids. Our sun is located on the edge of the Milky Way galaxy. If you look at the picture on this slide, our sun is right here, actually on one of our spiraled arms from our Milky Way galaxy. We are not located in the middle. So there's 3 types of galaxies. The spiral galaxies are shaped like discs with a bulge in the middle. Spiral arms seem to wind outward. You can see this is from the Hubble telescope, and you can see there's a disc in the middle, or a disc shape in the middle, and then the arms kind of spiral out. And this would be a spiral galaxy. An elliptical galaxy looks like spheres or flattened spheres that are bright in the middle. Here's a Hubble telescope picture of an elliptical galaxy. And then finally, your irregular galaxies. There's no specific shape or pattern to these galaxies. No 2 irregular galaxies necessarily look alike. A galaxy cluster is a group of galaxies that are clustered together. The Milky Way belongs to a cluster of 32 galaxies called the local group. A supercluster is a group of clusters, and then these superclusters make up our universe. So all of the superclusters form the universe, and the universe consists of everything that exists in space. So go down to the very last tab on your foldable. This is the flow chart of a life cycle of a star. And let me go ahead and get you to copy this down. This is the life cycle of a star. A star will start out as a nebula and then forms a protostar, and we'll go over what those are. From a protostar, a star may become a red dwarf, a yellow star, or a blue giant. These are your main sequence. And then a yellow star or a red dwarf may become a red giant as it begins to die, whereas a blue giant would become a red supergiant. From there, the path that it takes follows the flowchart. Red giant, as it continues on the end of its life cycle, would become a red dwarf and then a black dwarf. Whereas the red supergiant will eventually become a supernova, and then a supernova will either become a black hole or a neutron star. And that should be the very last tab in your booklet. Now, if you'll go back up to the tab entitled Mass of Star, the mass of the star determines how long a star lives. A small mass star uses less fuel, so it lasts longer. So the smaller the mass, the longer it lasts. A large mass star will burn up very quickly and die sooner. Okay, your nebula. A nebula, all stars start as a nebula. It's a large cloud of gas and dust. And because it is a large amount of gas, it's in a very small volume and it's very dense. And this is a picture of a nebula. Your protostar, this is the first official stage of a star's life. It's a contracting cloud of gas and dust. You can see the middle of it here. And the pressure and heat is what start the nuclear fusion that is required to form a star. So your main sequence period. This is the main life period of a star. It can be classified as either a red dwarf, yellow star, or a blue giant. The red dwarf is a small mass star. It can last up to 200 billion years, and it has relative to stars, it has a very low temperature. A yellow star is a medium mass star. Our sun is a yellow star, and it lives for about 10 billion years. Yellow star has about medium temperature. It's in between the red, higher than the red, but lower than the blue. The blue giant, it's a very large mass star. It is 10 to 15 times larger than the sun. It is extremely hot, and it lives a very short time because of how fast it burns its fuel. The red giant. This is a new tab. When the star runs out of fuel, the outer parts expand, then the core shrinks. It turns red because it's cooling, and this phase will last until the star exhausts its remaining fuel. The pressure of the nuclear reaction is not strong enough to equalize the force of gravity, so the star will end up collapsing. Now, if it's a blue giant star, it does not become a red giant, it becomes a red supergiant. Again, the star is running out of fuel, the core shrinks, and the outer parts expand, and again, it is cooling, so it goes from that hot blue color to the cool red color. This phase will last until the star exhausts all its remaining fuel, and again, the pressure of the nuclear reaction is not strong enough to equalize the force of gravity, so the star will end up collapsing. If a star were to become a white dwarf, that means there's no more fuel left. There's a faint glow from leftover energy. The outer parts drift out into space, any dust or particles, and a small blue, hot white core is what's left. It's about the size of Earth. If a star becomes a supernova, the core shrinks, pressure increases, and there's a massive explosion. And this is a picture of a supernova. Some stars will end up becoming a black dwarf, and after the white dwarf stops glowing, it's dead and very dense, and that is what a black dwarf would look like. Now, if it's a supernova, then it can become a black hole. This is the remains of the explosion from the supernova collapse into a black hole. Most large mass stars turn into black holes. Or it can become a neutron star. After the explosion, some material left behind forms a neutron star, and it is very dense and small, and that's what it looks like. And that is all. Please make sure you finish your foldable. It is due Monday. Thank you.